All right, so starting off, does anyone have, bringing it back up to like the platforms level, or maybe not, I guess we had another question before that, but do you want to go ahead?
I don't know, mine is not platform oriented.
Oh, you go ahead.
But it kind of even stems from the original session. I think we talked a lot about neural data. There was metadata sprinkled here and there. Then you mentioned that which t-shirt was brought into the room was important, right? So there is lots of metadata and other auxiliary data which is actually important to create possibly models which are explaining more variables, right, than what we can explain just by looking at neural data, right? So how much of attention do you pay to capture all that nuisance or auxiliary metadata and data about the experiments while doing your experiments? You show them visual stimuli. Do you record actually what was the visual stimulus? So maybe somebody could create low-level model of, I don't know, how vision propagates. Not just left or right and probability, but actual visual stimulus. Did you record the gender of the experimenter who did the experiment? Is that metadata provided with the data set? So that's pretty much the scope of the question.
I mean, at the Allen, we do record the gen. I think the operator is, I think, is blind. We don't release it, but we have it. I think the community is maturing in the sense of like understanding that we really need to record a lot more over the years. And so it's definitely true that early on, when we started the pipeline, we would not record as much as we do today. Like now we have much more cameras and have like a very thoughtful attention to metadata. But I think, but mostly the same as most academic labs, and since we are sensitive about it.
Capturing metadata is another one of those very difficult problems that nobody wants to do, simply because the tooling is difficult to use, right? So I think there's a real gap right now. As Jerome said, after you collect data for a few months, you realize, oh shoot, I needed to measure, when we turned the lights on in the room, that was actually super important and we forgot, right? So we have this long list of 100 different things that's important to remember to keep track of, but if it's really hard every day for somebody to enter that information, they're not going to do it accurately. So there's a tool gap there that I think needs to get filled.
I have a funny story on that. At the beginning of the 2P pipeline, there was a lot of drift in the morning and not the afternoon. And then we started to record temperature in the room, and we saw that, when you ramp up the rig for the whole day, the temperature will stabilize. And so now, you care about temperature.
All of those should be automated, right? So maybe that's what we need to work on, not to just improve recordings, but improve automated capture of like we are capturing humidity and temperature in our scanner, right? We are capturing all audio, video stimuli delivered to the subject. So we should maybe come up with guidelines for the labs how to capture all that.
Well, we also had a problem with this because we thought we wanted to put a microphone. We did put a microphone so that we would record all the sounds, because you never know, somebody walked into the room, made a sound, and a neuron fired. And then we released the data, and now we realize if somebody had a confidential conversation in that room, it's actually shared with the planet. But anyway, just it still is. Just so you know, there is such a thing as oversharing.
I guess for that, you have to have an IRB then?
Yeah.
I'm serious though. I mean, if you're recording the gender and the smell of people, I mean, this is a whole other ethical question too, right?
Recording smell is very hard.
Yeah.
Sure, the natural spectrometer, right?
Yeah. Can I just add a single word about the smell thing? I think that the reason why these variables, they were so esoteric, were important, is that these studies were measuring some abstract preferences of a mouse. Does it prefer to sit over there or sit over there? Is it scared of heights? Things, whereas in the tasks that we do, and in the Allen Institute does, they're much more like, there's a task, there's a thing to do, there's a stimulus, and so I think that those are much more reproducible than, is the mouse going to be scared of bright lights, which might depend then on the smell that is right there and things like that.
I have a general question. When we are talking about in these sessions a lot about what we can do to capture metadata or how to standardize things and so on, and most of us seem to be on the side of data producers, right? And we are trying to put ourselves in the shoes of what people will be needing when they start analyzing the data, would it be helpful as a community to have a group of people who are specialized on using the data that has been already generated? Because I think in that way we can learn the best on what kind of data, what kind of metadata is needed, and then be our effort be guided by those insights instead. I haven't seen, for instance, many papers that talk about the data that has been stored somewhere on some servers and so on, and that they have used it as the basis of their analysis or discovery, for that matter.
As someone downstream in that pipeline, I'm going to say, I think it would be really helpful. But the panel, does anyone have strong?
Well, we've done a little bit of it because we couldn't tell people what to do because they're in different labs, right? So half of the labs were running the mice on the inverted schedule, and half were doing on the normal schedule, and we couldn't go to these labs and say, no, do it this other way. They were using different feed, different, all sorts of stuff that for you guys, it's like you just do it one way, whereas we had 11 labs. And so the only thing we could do is write down what people are doing. And we did a lot of that, and we actually documented exactly what we wrote down. Then we were able to go back and, for example, ask, is it true that you need to keep mice in an inverted schedule because they will perform better? We see zero evidence of that, by the way. We didn't publish it because it doesn't seem that interesting, but we don't see any evidence of that. But so we wrote down as much as we could, but we couldn't boss people around.
So what I meant is just people who are then using those data in order to do some discovery, doing analysis and so on, right? They could be guiding then the kind of things that they would be caring about, right? The formats, what would be missing, et cetera, et cetera. The things that we are just trying to come up on a talk basis.
Yeah, I feel like there's two groups that are missing right now. One is moderately well represented, but not huge, is the tool developers, right? And often these are people embedded answering their own questions, but people specifically who are trying to develop analytical tools to support downstream analysis. So there's a few of these people, but it's not a huge community. But I don't run into very many people who are simply trying to consume data and from not collect it themselves. We run workshops regularly, and oftentimes the people that come to these workshops are people who we train how to do analysis, and then they go back to the lab and collect their own data. Right. So I agree, it's a gap.
This is the dimension of success,
Yeah.
because we are sharing all of this data, but the consumers are not.
Well, and if it turns out we should be jamming all of our data into generative modeling platforms, like our file formats probably aren't right? So 100% agree.
I had a platform question, maybe not really for David, but more general. You're trying to hide a lot of the complexity of doing cloud computation, and I was wondering in particular how money gets into that. You talked about you need this public or paid account for CodeOcean, and cloud, you get charged by the amount of computed amount of data. So you really want to know ahead of time what pushing that button is going to do. And one of the things about that makes it hard to use a lot of the cloud tools that are out there is they don't hide that from you, so, which is arguably good if you're trying to watch your budget. So I'm wondering how handling that issue for things that aren't going to be free when it's so simple a grad student might run up pretty large bill.
Yeah, there's a lot of things I can say about that. One is, so I can't not say that Amazon's being very generous with us with storage. So there's very little of our storage that we have to pay for, and oftentimes that's a cost that dominates in cloud. So important to say out loud, and we're very happy that they're doing that, as I'm sure Dandy and others are. The other thing about being nervous about running up bills, right? So that happens, that has happened to the Allen Institute before, and sometimes it's pretty scary. But some of that is because I think we're putting people who aren't trained to use tools on the tools, right? And so if you go walk into the Amazon AWS Cloud Console and have a scientist just like, go do whatever you want, yeah, that is super risky, right? That is not something I would tell anybody to do. And so that there has to be a user layer in front, so a tool that's designed for scientists that has guardrails in place so that they can't do that, right? And for us, that's CodeOcean. That's a thing that I have control over. Like, we can only run pipelines only so large, and someone's got to talk to me before it's going to get larger than that, right?
So just to press on that, in particular, you have guardrails that people can set, don't run anything that is estimated above some value?
It's not at the dollar level, but it's at the compute hour level I have control, yeah. Yeah, they're equivalent. Yeah.
Jim?
Guys, I was wondering, good to see you, Matteo, all of you. I was wondering if you guys could, I hear a lot of the discussion about, hey, we gotta record this, we gotta do that. All of that sort of uncertainty about everything that you need to write down. Like, well, first the good forces write down more the better for some future person that you can't imagine. But of course, that is an unending, impossible task. And it's sort of reflecting back to the question that was essentially asked in a different way, which is like, some way experiments are supposed to be to test ideas. And could you argue, like, maybe there's just a lack of ideas and specific predictions here as a sort of, and how do you guys think about frameworks for supporting that rather than frameworks for just holding data repository? So I mean, now I'll highlight things that some of us in the room have been working on, which is not just a data platform, but a benchmarking platform, which forwards predictions as a key part of that. Can you guys comment on how you think about that? And even Matteo, when you said, hey, this was reproducible, you put up the side of a different paper. Like, well, for some things that you went to ask are reproducible, but that was essentially hypotheses in your head embedded in even those experiments, right? And we're sort of not that explicit as a field about like what are we actually testing in this notion of, well, you test everything and then you get heartbeat and all the problems of that, right? And so, I don't know, it's a important question, but what if you could come at this from the other side a bit more and how you guys think about that as a sort of at least partial answer to all the problems you're trying to solve, if that makes sense.
We almost on purpose in this first pass of the data did not test hypotheses, almost on purpose. Look, we wanted to run the things that everybody would say you have to run because it's obvious, like, right? And then ask very simple questions like, are things localized or not localized? We wanted to embrace the brain-wide aspect of it. But we have barely scratched the surface. I mean, one could go look at the fine time structure of the activity, when neurons fire together, a lot of them are recorded at the same time. There's such a wealth in there, and I can only hope that this is exactly what people will use the database for, is to test hypotheses. But we did not think, to be honest, of a benchmark system in which, like, we ask people, predict the activity of these neurons that we're not showing you, which is, I think, the kind of thing you did in the visual system, which is super cool.
Which also leads to hiding data at some point too, right? And so that comes in, transparency is not always the right.
Yeah, no, exactly. It's great to keep some test data on the side and say, tell us what you think these neurons are going to do, and we tell you how good no, we actually didn't think of that. The fact that the neurons are not collected all at the same time makes it a little bit trickier here because there's so many other variables. But I'm curious what you guys at Allen think about this.
I have some thought on this. Well, first, if a community of theoretical scientists wants to put together a community proposal that tests different ideas and have a really clear data set that would advocate for different aspects, go for it. That's a gold use of a platform like OpenScope or over to come. Yes, because I think biologist likes to find new layers of complexity that has never been found before, but a physicist sometimes want to test ideas. There's different approach to neuroscience, right? As you said, you can be data-driven or hypothesis-driven, and there's a room for, that's why we built this, is to allow everyone to test hypotheses. You don't have to build the experiments.
Dr. Okano has stayed up so late for us.
Yeah.
I'd like to ask him a question. You may have to repeat it.
Sorry, can you go ahead again?
Yeah. So what I want to know is he's gone to this immense trouble to make a Tourette's model in a primate. And I'm always, people do rodents because they're easy, not because they're important. Can he give us any insight as to any prior models of Tourette's in a system other than the primate, and how well matched are they?
All right, did you hear that? Would you like me to repeat it for you? Yeah, so the question is, in fact, we probably should have. Yeah, so the question is, given the immense difficulty in modeling the primate, and actually, you know what, instead I'm going to pass this back.
Sorry, it's not Tourette's.
Right, sorry. So what I would like to know is that you've done this immensely difficult thing to make a Rett syndrome model in a primate, and I would like to know whether that has led to any insights as to the validity or weakness of any similar model in a rodent or any other animal that's been previously published?
Yeah, so actually, so we're comparing the lots of the behavior and also gene expression, and so and also target domain P2 between the across the species, and so there's a significant differences, even the same molecule, the target of the DNA and also gene expression and the network and the differences between the mouse and so mouse. So as you indicate that, so similar so differences in other models. So for example, so it's not neurodevelopmental disorders. So the effect of the APP, so mutations, the Alzheimer's disease model, their behavior, their effect in the brain circuitry and so function seem to be different with marmoset and mouse. But so we still don't know. So the theory or hypothesis how to we can predict between the rodent and so primate models. We need more data.
So we.
Shaxi comparison, Shaxi mutant, the marmoset and macaque and the rodent will tell us an answer. But we still don't know the uniform hypothesis yet. Okay? We need more data driven.
We are a little bit over time, but I think we got. Oh, sorry. We're a little bit over time, but I think I saw one more question over there.
Yeah, along the same lines, I'm wondering what the state of electrophysiology work is in the marmoset model, whether there's been any data harmonization with the mouse platforms.
The question is about the state of electrophysiology and the, was it the mouse platform that you're interested in?
Whether it's translating to the mouse.
And whether it's translating back to the mouse.
Okay, we're going to do this two-photon based imaging of the marmoset, and so wide view, and so as you know, okay, Lecoq has developed a very continuous wide view two-photon microscopies that can be applied both mouse and so marmoset, and so we wish to compare the difference and similarity of the circuit levels and its effect of how the genetically mutation affects those circuits function in both species. We are still in the middle of it, so maybe we have data maybe next year into a couple of years.
All right, I think we should wrap it up for now. We'll go have a quick break for coffee. The restaurant is back in